No, that's the Scream Machine. Who said Scream Machine? Great American Scream Machine. So for those that don't know, Great American Scream Machine was a 173-foot tall ride, opened in 1989, the tallest and fastest looping roller coaster in the world. It had 7 loops, including a batwing and a double corkscrew. It operated until 2010. And right now, the top of the original first loop can be found at the monkey enclosure in the Wild Safari. And here's a picture. You see, got the little monkey over there. That's so anyone who walks through the safari wonders what that loop is. That is the loop from the Scream Machine. That has nothing to do with my talk. I just thought that was interesting. Let's go. So let's talk about real loops. So we're going to have the agenda. We're going to show some memes. Obviously, I apologize. I'm just very immature and I never really grew up. We're going to talk about callbacks and promises. We're going to have a little demo and then there's going to be a quiz. Be nervous, okay? Be very nervous. So, whoops, doop doop doop. Clicker. What is the Scream? What year was the Scream Machine? It's going to be, what year was it? Did it open? That's when it closed. What year did it open? Okay. How many people, I'll go backwards. How many people don't use JavaScript on a daily basis? Do not. Okay. How many people are completely unfamiliar with JavaScript? Like completely. Oh, come on, Ellie, stop it. Okay, I just want to know. So, okay, just wanted to know who it did. But most of you, it seems like at least more than half, like are know JavaScript. Okay, cool. I just hope, hopefully everyone will learn. There's something for everyone here. Just as I go through the, I'm going to try to level everybody to go through, talk about callbacks and promises, to sort of level the not level the playing field, but sort of set the baseline over here and what this event loop thing is all about that we keep talking about. So callbacks are pretty straightforward. This is like ABCs of JavaScript. Oh, it's backwards. Yes. So yeah, you want to hear so JavaScript's callbacks. Callbacks they're all over the place. What's a callback? A callback is basically a function passed into another function, which is then invoked inside that function. Pretty simple, right? Callbacks are usually, not always, used to continue code execution after an asynchronous operation has completed. So what does that look like? In the browser, event listeners use callbacks. So we pass a little callback into there, little arrow function. You click the button when you click the button. In Node, it may look like something like this. You can read a file, and you give it a callback, with which will always return error first. That's the Node standard. That's a callback, right? These are both asynchronous. These are both asynchronous operations. But this is like the basics of JavaScript that we know and love, or most of us love. Some of us, whatever, may. What's promises? So yeah, so we callbacks were around forever, since the 90s, for however many years we were doing JavaScript from, and then about 10-ish years ago, don't quote me on that, a bunch of years ago, insert number, and a number of years ago, promises came on board. So what were and promises? They promised that it was very promising at the time, a new abstraction over asynchronous operations. So basically, what is a promise? A promise, it's an object returned from an asynchronous function that represents the state of that operation. You pass a callback to it, and it'll be executed. You use either then or catch chained onto the promises. We could see what that looks like, but then the idea is that instead of you're still passing a callback, but the value of this asynchronous operation is represented by this promise object. What does it look like in the browser? So fetch, the fetch API. So that's catasaservice.com/cat. If you just it's very if you need cat images, there's cat as a service. It's real. So then is a method that you call on the object that will get returned from the fetch function. Here you get the blob, and then you could assign it to an image, or you could do whatever you want with it. That's what it looked like in the browser. In Node, it's the same file, just using the permissified version it's the same function, of reading that file. It's just using the permissified version of read file. So it's instead of passing the callback in, there's .then, and then .catch is to handle errors. That's callbacks, and that's promises, and that is how we do pretty much everything in JavaScript. All useful things in JavaScript in the browser, whether it's events and observers and API, network interactions. In Node, it's I/O, everything revolves around callbacks and promises. Any questions so far? Good. So for those new to JavaScript, a lot of people come into JavaScript and like they're learning about this stuff. Like one of the first questions that are usually asked is like, why so asynchronous? Like why? Why is like not every programming language has this model where every thing that you do that's is done asynchronously, that you need to have callbacks and promises for all these things. So the answer is like less. It's really not. It's not that important. I put words here because I needed words. But like basically, the idea is that JavaScript was sort of like written to work in the browser, and the browser has a lot of things to do. It has to work with the operating system. It has to work with the network. I mean, through the operating system with the network. It has to listen to events. It has to paint to the screen, right? It has to do animations. It's very, 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 very busy. And like the browser is very busy, and JavaScript is meant to interact with that, to update the DOM, to listen to events, and all that stuff. That needs to run on the same thread. Otherwise, you'll have race conditions and managing events and asynchronous and parallel operations using threads while trying to get the browser to render to the page is just a bloody nightmare. So basically, so JavaScript sort of needs, the language doesn't need to be, but because JavaScript was meant to be used in the browser, we sort of need it to be single-threaded, non-blocking. Otherwise, the browsers wouldn't be able to paint and wouldn't be able to render. So we basically need a mechanism to handle all the stuff that's happening to avoid race conditions and sort of ensure a deterministic order of events. And that brings us to the event loop. That's what this whole talk is about, is the event loop. Every browser has the event loop. It's not part of the JavaScript language itself. It's sort of part of like the whole shebang. So there's like, this is like sort of representation of what the event loop might look like in the browser. So you have the web APIs. The web APIs is the stuff that the browser gives you, is like tools that the browser gives you that you have access to within JavaScript, and you could do things like set timeouts. You could access the DOM, excuse me. You could access the DOM. You could access the network using fetch, all that stuff. What happens, and then there's the main call stack, which is basically where JavaScript stores all its basic JavaScript-y stuff that you want to do. You could log, you could do things and stuff. But how does it work? So the way it works is there's sort of like this cycle. The event loop is just a loop. It's literally a while loop, as we will soon see. It's literally just a loop that goes round and round and round and round. The web APIs, right? So just, I'm going to go back. When I said single-threaded non-blocking, obviously there's lots and lots of threads in the browser. JavaScript itself is single-threaded. But the browser has plenty of threads, and the browser is doing its things. And so it has APIs, and it's managing all these things on its separate thread, on a separate thread. When it's ready to do something, it will call back and put something back on a callback queue. The callback queue is literally just a queue, first in, first out, right? First in, first out. And it basically will have all the callbacks that you have for the different events. So click handlers, load handlers, done, right, which represents timeouts, DOM operations, fetch, all that stuff. As soon as it's ready to do something, it will throw it onto the queue. The event loop is running, turning. It sees something on the queue. OK, it will throw it onto the call stack. It will run it. And it will just keep spinning, waiting for something on the queue, and then it will run it. And in between, the browser, while the loop is spinning, the browser sort of has time in between all these operations to do the other things that we spoke about, of like basically painting to the screen to make sure we don't have jank and to make sure our web pages are beautiful and we can buy bathtubs from Quality Bath. That's basically it. Node is not so different. It's a little different, but it's the same idea. It uses thread pool, but it still has the main components of the event loop. It has the event queue. It has like the I/O coming in, and these are all the, it uses the thread pool to sort of, but these are all like the APIs that it gives you, database file system, network APIs, all the APIs that Node gives you. It's the same idea. It will use, the core JavaScript is running, this event loop is queuing up events, and JavaScript will. You are correct. Sorry. Thank you very much. That is one of the differences between JavaScript and the browser and JavaScript. So I want to demo this. So demo what? So I want to demo, like, like as cool as these pictures are, I'm pretty sure that if I'm pretty sure I did not do a great job explaining it to someone who has never like really seen this in action before, or at least paid attention to how it works when seeing it in action. So I definitely want to demo it. I couldn't really figure out how to demo it. So I mean, not that I couldn't figure out. Like, there are predecessors to this type of talk. Many of you may have seen the talk on YouTube called like "What the heck is the event loop?" Anyways, and a guy, Philip Roberts, he wrote a tool called Loop, which sort of represents like the way, like it has the call stack, the web APIs, the callback queue, and sort of like has a cool UI that's like written in Rust, I think, or some sort of system thing to sort of monkey patch the JavaScript runtime. This is like an image from a talk from Jake Archibald from Google, or he's no longer at Google, was at Google at the time that he gave this talk. He used like these actually very good like animations to like represent like the loop and like the different things that the browsers do. So I was trying to figure out which was the best way to demo it, and then I remembered this. Jeff Atwood's law: any application that can be written in JavaScript will eventually be written in JavaScript. So me, in my like I said, I may or may not work for Meta, so I have a lot of time on my hand. I decided what's going to happen if I write the JavaScript in JavaScript. Let's see how it goes. Any questions before I start? Okay. So we are going to live code. I'm joking. We're going to do a lot of cut and paste. Live code what the event loop looks like in JavaScript, like if we were to implement it in JavaScript. So we're going to start off with a blank file. So the first thing we have to do is we have to write a loop, because that's what the event loop is. And literally, it's literally a while loop that just spins and spins and spins. The problem is, if I were to write, while true, I don't want to finish it. If I were to write while true and actually run this code, which is running in the background, it will absolutely freeze up and lock. That's what we call a tight loop, and it's just going to completely lock the thread, and then whatever, I'll have to switch computers, or it's not going to work. So step one is just I wrote a little helper function, a little while true loop helper function. This is called what we call trampolining in like functional programming, whatever, where you basically have a method just runs, and I just keep queuing it up using set timeout. Can you guys see in the back? It's very dark, but yeah, you see Ozzy? Yeah. So basically, this is just a while true loop, and it basically while true, it'll just run this. And I set the timeout at a second to sort of just like throttle my loop over here so we could actually see it in action. So step one is to actually just write a while loop. Okay, so while true, and we refer to each step of the each turn of the loop, we refer to it as a tick. So this is like literally a tick. So if I were to refresh the page, go tick, 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 and here's my while loop. Every second we have a tick. Okay, good. So now we need a queue, right? So really, so now we have a queue. What's a queue? A queue in JavaScript. We just represent it as an array. Pop, shift, pop, shift, pop, shift. And while true, like on each tick, we're going to say, hey, if there is something on the queue, we're just going to shift that off, take the next thing on the queue, which is going to be the next function, and we're literally just going to call that function, and that's all there is to it. So, so all we need to do is if we just push something on the queue, right? So if we just push something on the queue, what am I pushing on the queue? Oh, a method, right? That, so that will just run at a certain tick of the what's it called. So how do we get things on the queue? So this goes back, going back to this slide over here, right? So we have the web API. So let's grab the web API is what pushes things, right? The arrow going this way, counterclockwise, because we're in the browser. Set timeout's gonna be the first one. So let's implement set timeout. So what does set timeout do? I mean, everyone knows. Does anyone not know what set timeout does in the browser? Set timeout is basically you just pass it a function. It looks like this, right? You know, set timeout, and I'm gonna say set timeout in like, 3 seconds. What should I write? Hi. Just hi. Oops. So tick, 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 3 times, 3 ticks, 3 seconds, hi. But this is the browser. This didn't really use my loop. This used the browser's loop. So I wanted to use my loop. So I'm going to write my own set timeout. Okay? Write my own set timeout. So function. So now, the only way to really do this, and again, what's set timeout like? Like we said before, there are threads, right? If I go back to here, there's definitely threads going on over here. It's just we don't, the thread, like we're not managing that thread. But for my queue, I'm going to manage that thread. And the way to do threading in the browser is through web workers. So all I did was just move the set timeout to a web worker, and I'm literally just posting a message back. Hey there, you'll send me over the timeout amount, and I am going to call back to you after that amount. So I'm just basically throwing a function, just throwing a timer onto a thread, and that thread will call back. So let's implement that. Let's add that to our thing. So, oops. So what are we going to call it? So I can't call it set timeout. So I'm going to call it please hold. Please hold, right? Spin up the web worker. I'm going to post to the worker. I'm just going to post the amount of milliseconds that you want to hold on for. And then on message, I'm going to do exactly what I did before. I'm going to push it onto the queue. So I'm not calling my method. The web worker is also not calling my method, right? The web worker is just posting back after a timeout, right? All I'm doing is pushing onto a queue, and my the event loop is going to call that function for us. It's going to pull it off the queue. What's it called? So let's please hold for 4 seconds. Console.log. Thank you for your patience. And let's refresh the page. Tick, 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 tick. Thank you for your patience. Thank you for your patience. It took 5. I don't know why. Whatever. I know why, but irrelevant. So I basically implemented set timeout. I just renamed it please hold. So that was step. So that's callbacks. So that's how callbacks work, right? You pass this function as a callback. The browser will sort of do its thing in its own thread. It will call back. It will push it onto a queue, and then the event loop will just pick it up when it's at its earliest convenience, right? The event loop over here, counterclockwise. It will put it onto the call stack, and that's that. So that's set timeout. Now again, set interval would be as simple as like, I'm not going to demo that, but like to make like a set interval would be, what would I call a set interval? Say like, do it again, or keep on doing it, whatever. It would be the exact same code. It will just do a set. What was that?
Please repeat.
Please repeat. There we go. Please repeat. It would be the same thing. It would just spin up that thread every single time. It would just keep spinning up the thread over and over again, calling back. What? It would push whatever the interval is. It will just keep pushing it to the queue. But now it will probably have. What is that? There's one queue. There's one queue, and it's just literally queuing up functions to be called. It can if it wants. I'm saying, will it, or what are you asking? I want to make sure I understand the question. It's set for set interval or set. Oh, so I didn't implement it. So how would it work? I could use set interval in the web worker the same way, and it would just keep what's it called. Yeah, I would probably just use set interval. I mean, I would do it live, but I don't want to embarrass myself if it doesn't work. But yeah, you'd probably one of two things. Either you do what you said. Either the thread, you could just like write like a trampoline type of function where it'll just call itself again once it's finished. But that's not true. I'm not sure if that's true to the spec, like set interval, because if that takes more than the interval, the browser will actually run it twice in parallel. Not parallel, whatever. It won't wait. So I would have to look at the spec for that. But again, the idea is the same. The idea is the same thing. However, you're going to make it repeat that thing. The idea is the same. Is that it will this code will not call your function. It will queue it up. It will queue it up, and it will run it at its earliest convenience. So that's callbacks. Fetch uses promises. So here we're gonna get a little hairy over here, and we're gonna write a promise implementation. Please, if anyone actually has ever done this before and knows the spec better than me, please don't embarrass me. This is not the spec, but basically, here we go. We are going to write a nether. Nether is Hebrew for promise. For those that don't know, I just couldn't reuse it. Okay, so what's the, hold on, I just want to cut and paste a little bit more code. We're going to work backwards over here. I'm going to show you the I'm sorry? Nether.resolve. I don't need it yet. I'm going to need it soon. But, okay, fine. Where is it? Nether.resolve over here. Thank you, Mr. Tukutsky. We're gonna work backwards. So for those who are unfamiliar with promises, a promise is it's a class or whatever. It's a function, a constructor function. I don't want to say class because this is JavaScript. There are no classes. Don't tell me that there's classes. But basically, it takes an executor. Thank you, WebStorm. You see, imagine if I wouldn't use JetBrains. It wouldn't say the word executor. It takes an executor, and maybe because I named it. Yeah, it is. Okay. It takes an executor. Executor is a function that gets called synchronously. It takes a function, a callback function. It gets called synchronously right away. It passes in resolve and reject. I purposely ignored reject because I just didn't want to overcomplicate this thing. Resolve is basically is the function that you call with the value that you want to represent in the future. So think API call. It's going to take a few seconds for the data to come back from the API. You resolve the promise with that data. Yeah. So in this case, I will just call my please hold for 5 seconds, and I will just resolve with 7. 7 because there were 7 loops in the screen machine. And then you call, okay, so that just actually runs it. But in order to actually do anything with the value, you have to call .then and pass a callback to .then, and it will get the value eventually. It will get the value eventually, and it will run the callback. Now, in this case, if you notice, right, this gets run synchronously, but this gets thrown onto a thread, and it only gets queued up 5 seconds later, but this gets called right away, right? So this gets called up right away. So we sort of need a mechanism to sort of hold on to all those callbacks that we queued up using .then and run it at the time that the promise gets resolved, that the nether gets resolved, gets mukuyim. So I just wrote a quick little implementation. It takes the executor. We're going to call that synchronously soon, but basically it's going to maintain an array of callbacks, and then it's going to have a state. The state can either be pending or fulfilled. There's actually 2 things. There's states and fates, which is like fulfilled, and then this pending or fulfilled, and then there's whether it got resolved or rejected. But I've simplified this a little bit. So there's a state, and then there's the value, which defaults to null. We're going to define .then on this instance. Really, this can go on the prototype, but whatever. We did it on the instance. And it basically, every promise returns a new promise. That's every call to .then returns a new promise. That's the spec. So you could just chain things. So it will return. So we sort of have like a recursive definition over here, which is cool. It returns a new thing. I define like a call method. This is like the actual call to the callback, which it will do. It will call it. It will take the next value, and it will resolve the returned promise with the value that gets returned from the function that gets called to dot then. If that didn't make sense, I'll demo it in a second. But that's sort of what you have to do over here. And then here's the most important part for the purposes of this talk. If it's still pending, meaning we don't have a value yet, it will just push it. It will push this closure over here. It will push it to the callback, to a collection of callbacks that are encapsulated within this neder, this promise. Otherwise, it will push it off to the queue. This is the same queue that set timeout and please hold. What's it called? Pushed it onto. It will push it onto that queue. The executor gets right at. So these are all just definitions, right? The executor gets called. Then we call the executor synchronously, right? And we pass in. If you remember over here, we passed in resolve. So now we're going to define resolve. Resolve is just going to be another function that we're going to resolve it with that value. So then it's literally just, it's going to assign the value. It's going to flip it to fulfilled, from pending to fulfilled. And it will just loop through the callbacks and push the callbacks onto the queue. And it's done. So the promise itself, even though it's providing you with .then, it's providing you with .catch, which I didn't implement, and mechanisms to call back with that value, but it actually doesn't call anything by itself. It just calls, it just, back to our picture, it on done, it will just push it back onto the queue. Everything just gets pushed onto the queue, and who's running things on the queue? The event loop. The event loop is just while true, and it's just tick, 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 pushing these onto the queue, calling the code as it does. Promise.resolve is just sort of it's a static function that if you want to just create a promise that's already fulfilled, you sort of just create it with the value. So this is basically, this will just run synchronously. It will return this. This will run synchronously. It will resolve it with the value synchronously, and you will just have a promise that you'll be able to call .resolve. So .resolve will sort of like, you know, netter.resolve, resolve it with 7, you know, .then, console.log. So yeah, this will just log. Wrong way. 7. Beautiful. Shame. Now, about this thing before about chaining. Right, the reason why we return a new promise is because we can chain things. We could say .then, you know, alert. Right? We could like log 7 and then alert 7. Alert undefined, clearly. Because console doesn't return. Okay. But yeah, we'll just have to do val console.log val. What comma? Thank you. Who does this? Why would I know this? Oh, and I have to do. It's not gonna work. I have to do that. Yeah. Return. What? Okay, how about I just don't do this? Okay. Oh my gosh. Fine. So in order to be able to chain it, so we need to sort of return that. So that's the way things. If I want to go really crazy, if I want to go really crazy, it also unwraps promises. Like if a promise returns another promise, they sort of get hoisted monadically. I had to say that. Yes, I said monad. So that's that. So that's promises. See this in action? Did we see this in action yet? We didn't. No, we actually didn't demo this yet. So we're going to wait we're going to wait 5 seconds, and then we're going to say thank you for your patience, and then we're going to say the value is 7, because that's the value. Good. Okay, that's my demo. That's not all. That's not the end of my talk. What? The quiz is right now. Hold on, I have to. Quiz. Okay, I showed the slide, and now I'm gonna go through the quiz. Okay, so based on what we learned, what? 7 loops. Oh, that's. Based on what we learned, what's this gonna? What's this? So we're gonna. What's gonna come out in the console? Oh, I'm gonna hide the console specifically. We got a console log script start that gets run. I'll give you that. That's gonna get logged first. Okay. we're going to set timeout to 0, which means throw it right on the queue. And we're going to log set timeout. Then synchronously, we're going to call promise.resolve. And we're going to chain two things. We're going to chain two .thens. One's going to be promise 1. One's going to be promise 2. And then the script is going to end. There will be 5 console.logs. What is the order of these things based on what we learned? So start, end, obviously. And then which comes first, set timeout or what? One timeout 2. OK, so you're saying timeout's going to sort of get like stuck in between. OK. Anyone else? What was that? Avi.
First one, script start, set timeout, script end, and then 2 promises in order.
OK, so we got three different answers so far. Let's get a fourth. It's going to be the order than it is. That's the same thing that's not. That's what Avi said. That's not what Avi said. That's another. OK, so this is not going well because the actual what I was hoping you guys would say is script start, script end, set timeout, promise 1, promise 2. Did anyone say that? Forgive me if someone did. I don't think anyone did. Oh, so why set timeout last? That's a very good question. You're almost right. So script starts, script end we understand, right? Those are because it's synchronous, right? And like if we saw in our code, the while loop is running stuff in the queue, but like everything else just the rest, all the code running down here is run synchronously. Like the actual, like your main code on your JavaScript stack is running synchronously. So that we understand. Start and stop. What? It doesn't start picking things up the queue until it's finished doing what it needs to do, and then it will look at the queue. Right? So the queue is running, the loop is running, but it won't pick things off the queue until it's sort of like idle type of thing. What?
Is set timeout being put on the queue?
Oh, so set timeout is being put on the queue. So why, if it's being put on the queue right away, that should be the first thing on the queue, right? So why is that happening before promise? If really like this gets put right on the queue, this gets put on the queue, this gets put on the queue, right. Script starts, script end, then set timeout, promise 1, promise 2. That's what should happen. So let's see what happens if we, so this was in StackBlitz. This is real JavaScript. This is not Ellie Goulding code. Let's go to the quiz over here. And we are going to see, what happens if I could just cut and paste. So we're going to boop. Let's get rid of that. Good. Ready? This is the exact same code as before. It's just instead of using set timeout, it's please hold. Nether.resolve. Then promise. I don't need that. I don't know why that's there. Just because I wanted a value. OK, ready? Exact same code. Let us run it. Oh, let's get rid of the ticks because, oops. Let's get rid of the ticks because it's just getting in my way. I don't care. Thank you. That was useful. The counterclockwise thing wasn't. So we got a different order over here. So clearly I did something wrong. Because this is the script starts and promise 1, set timeout, promise 2, which this actually makes sense. In my implementation, it makes sense. Now, the reason why set timeout is between, which this is what you said, right? This is right. The reason why I set timeout over here is because of the way I throttled the loop, the way I throttled my while loop over here. If I were to move this down to 0 or 10 even, it would work better. Whatever. Yeah, there we go. Thank you. So this is what we saw in StackBlitz. But I'm going to put that back because I like my ticks. So what gives, right? So. This is where we come to the second part of this song. I'm going way too long. So I lied when I said there's a queue. I didn't lie. There's really 2 queues, right? There's the queue. Oops. We're going to rename this to the task queue. Okay. Oh, stop it. Yes, refactor. I said refactor. We're going to read into this task queue, and we're going to introduce a new queue. Const micro task queue. This is going to live code because I don't like cutting and pasting. Long story short, promises use a different queue than timers, than set timeout, and callbacks and stuff like that. It uses what's called a microtask queue, which has a different set of priorities, as we will soon see. So microtask queue. So all I have to do is go to my nether, and wherever I'm putting it onto the queue, instead of putting it on the task queue, I'm going to put it on the microtask queue. Okay. And when does the microtask queue get run? Right? When does it get dequeued? So over here, on each tick, we were dequeuing one thing at a time. The microtask queue, actually, while microtask2.length is greater than 0, right? So it's the exact same thing. I lied when I said I don't like cutting and pasting. This will actually run it in a while loop and just flush it out at the end of after every task. So after every task, so the while loop is going tick, tick, tick. On each tick, it's taking one thing off the task queue, looking at the microtask queue, seeing if there's anything there, flushing it out, and moves along its way. Which one goes first? Tasks go first. Tasks. So no, hold on. So I may have messed up the order over here. Microtasks go first. Yeah. So I did this wrong. So this is why you don't live code, right? I'm going to go to my final, and okay. So over here also the microtask. Okay. So I'll explain what happened over here. What happened is I didn't prepare well. No. So it's a bit of a misnomer. So I couldn't figure I couldn't figure out how to actually represent this. So really, the microtask queue gets flushed when the call stack is empty, not when the queue finishes. Just I couldn't figure out a sane way to do that. What? Put it in the next. Right after next. Oh, there we go. Okay. Hello. No, but this is not going to work because what if there is nothing on the task queue? Else if there's stuff in the microtask queue. So then flush that again. Live coding for the win. Pure code. What? What? I don't need the if. Oh, that's true. That's true. I don't need that. I don't know. I like writing more code. It makes me look smart. I don't know. So because it will, so in my case, it's not going to help. You're right. So in this case, it's not going to help. I'll tell you where it's going to help. No, I'll tell you what he meant. If I had some representation in this code of the call stack, but I don't. I only have the task queue, but I'm running in my code. There's synchronous code that's running before the task queue. What? Ready? I'm just gonna I'm just gonna put a big comment. Okay, I'm gonna comment my code. I'm just gonna move this down over here. No, for now I'm just gonna move this up to cheat. Now this is gonna work. Promise one. So that matched. Now this gets run when the call stack is finished. Now this puts things on the call stack, right? What?
No, in real JavaScript, it's not really possible.
In real JavaScript,
for the microtask queue.
To have anything correct. The point of this the point of this little what's called is just to show how my implementation sort of was a little in the first iteration was lacking because it only had one queue when really there are two queues, and this is very important because this actually this could come back. This could come back to bite you if you don't pay attention, if you're not careful to know exactly which types of callbacks in the browser use which queue. It could actually trip you up sometimes. So that's that. Why did it? No. No, this was done deliberately. Like this was actually not. The microtask queue was actually introduced well before promises. It was introduced when like observers were introduced, like mutation observer, resize observer. Like it was done on another gram. I think it's to make those things. What was that? Exactly. So I don't know why, but this is just the facts. This is just the facts. Yes, microtask. So callbacks go on the queue, meaning set timers and event callbacks from like listeners, from like event listeners, click handlers, and all that stuff goes on the queue. Promises and mutation observers, resize observers, all those stuff go on the Microtask queue. So are we done? Not yet. I had two more quizzes that I wanted to give, but what's it called? I'm going to skip that. This sort of is just a little bit a nice little example. Maybe I'll post this after to show how. You know what? I'll run through this quickly to show how. Like this is like a live example of like where things could get really confusing. So we have two boxes, one inside, one outside, the inner and outer. And here's a mutation observer. Like I said before, like it will see when it will listen to when the outside box is mutated, and it will log mutate. We'll also give a click handler, and the click handler will actually be the one that mutates it. At the same time, it will also call click, set timeout, and also set a promise that resolve. And to see how this works, like to see what order this is going to go in, if you don't know what's going on over here, right? The first thing that's going to happen is click, obviously, and then promise happened before set timeout because it's on the micro queue, right? Then we mutated. The second we mutated, right away the mutation observer was called from the Microtask queue. So right now, then because I clicked on the inner and we have an outer, right? It bubbled up, and it ran click again. It ran promise again. It ran mutate again because the mutate had like math.random in there, so it was like non-deterministic. And then it ran timeout, timeout. So this is like, but based on everything we just saw, because there's two separate queues and they're prioritized differently, this is why we get this thing. There's one more thing. There's not two queues. There's three queues, okay? And the final queue is the request animation queue. So I'm sure you've seen in JavaScript there's something called request animation frame. Request animation frame it looks just like set timeout. It just doesn't take the second parameter, and you just give it something, and it will basically you're asking the browser, hey browser, when you're ready to. Oh, I wrote this in code. I wrote this while sitting here while you guys were eating Mike's chicken. How you doing? Okay, ready? There's something called a render loop. So there's the event loop, and then there's the render loop. The render loop is what renders something to the screen. The screen, now the event loop just goes tick, 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 tick. The render loop, based on your screen, right? So this screen is, let's say it renders at, let's assume 60, this is not 60. Let's assume it's 30 hertz. So let's assume 60 frames a second. 60 frames a second is about around 16 milliseconds for every single render. So basically, if you have, let's say, 1,000 seconds and your frame rate is 60 hertz, so your interval is going to be 1,000 divided by 60, which is going to be 16, right? So you'll have this render loop. So it's also a loop that gets bounced back and forth, but instead of just going very fast, it's at a very, very specific interval based on your screen, right? In your render loop, it checks your request animation frame queue, which is a third queue. If there's anything on the queue, it makes a copy of the queue, resets the queue, flushes the queue, and renders. And that is what you do. And this is what request and how do you get something onto the request animation queue? You call request animation frame, and that will only run every 16 milliseconds. So I just call this do this before request animation frame is the worst named function ever. I think so. It's up there. Okay. So this is so I called it do this before you render, and it literally just pushes it onto the queue. If you want to see this in action, this is actually I have like two boxes over here, and okay, this is giving me a headache. Hold on. Ready? So I have two boxes. One's request animation, one's timeout. I'll grab each one. What did you say? What do you? Oh, yeah, seizure alert. I'm sorry. Well, basically, one is I'm just using set interval to just like move the position. Literally just set interval, and I don't give it a value, so it's literally just running on every single tick. As opposed to request animation frame, where I'm just using request animation frame and I'm not giving it a time. And if you look at it's like like request animation frame is nice and smooth because it's only 60. It's only updating the position every 60 milliseconds, as opposed to like timeout. Is like just, not only is it going faster, it's also a little janky because it's totally sporadic. It's like around every 4 milliseconds, give or take, is like when it's running. So it's just like. So if you're ever doing animations, use request animation frame. Don't use intervals for animations because that's just a silly thing to do. So in short, there's 3 queues. The event loop is just a loop that runs somewhere in the browser, somewhere in some thread, together with the render loop. It has 3 queues. There's a task queue, Microtask queue, request animation queue. They each have different rules. Remember we said at the beginning, it's deterministic. The task queue, items are dequeued 1 at a time on each tick of the event loop. Microtask queue, all items are dequeued after each task completes. We have to look into that a little more, exactly how to implement it in my little what's it called. But it's not after each task completes. It's when the JavaScript call stack is empty. And request animation frame, all items are dequeued right before the browser renders, except for the items that are added during that frame. That was my, if that's confusing, that was this code right here. It makes a copy because it doesn't want, otherwise it won't be able to render. You can't stop rendering. Say that again. I'm sorry. Yes, thank you. That is a great point. So correct, and it won't happen for intervals either. So this loop over here, this set timeout, if I want to freeze up my browser, if I switch this to promise.resolve, and I just resolve it instantly, and I keep running this loop, I will freeze my browser because of what he just said, right? The Microtask queue will just, it's always getting flushed. It's a while loop. If there's anything on the queue, it will not let you render, as opposed to intervals and timeouts where, so when using request animation frame, yeah, like the browser knows it makes a quick copy, and then it empties the queue, and then it flushes that copy in order to run. Otherwise, you just won't be able to render, and you won't be able to buy bathtubs. A couple of resources. So like I referenced this before. I plagiarized this, not plagiarized, whatever. This is my own version of like 2 talks that are quite popular on YouTube. What the heck is the event loop anyways? Jake Archibald. There's that tool loop that I showed you, which is very cool to check out. And here's this article that also goes very, very deep into this stuff where I learned a lot from it. And I'm finished. Any questions? Yes?
Could this